Okay, in this video I'm going to talk about average and instantaneous rate of change of function. First, let me show how to calculate, and then I'll explain the difference and the meaning of each one of them. So let us find the average and instantaneous rate of change of the function f of x is equal x squared on interval x and x plus delta x. Okay, so this is nothing special. This is the basic stuff that everybody who started learning calculus already knows. So delta f over delta x, that's an average rate of change, is equal x plus delta x, right? We are taking change of delta minus, it's going to be x squared, right? So ending point, a position minus the starting position, and divided by change, right? So this is going to be equal 2x delta x. Okay, let me go slow. I guess always I am trying to jump. X squared plus 2x delta x and plus delta x squared and minus x squared, right? So from here, this is gone, delta x, and we are getting delta f over delta x, and the result is 2x delta x plus delta x squared. And divided by delta x. Okay, let's divide by, since both terms in numerator have delta x, I'm going to separate them and divide by delta x. 2x delta x over delta x plus delta x squared over delta x. Let me this delta show. Okay, so this is canceling. This one is canceling with this, right? And then when we are taking the limit, delta x approaches to 0 because it's moving from end point to from beginning point to the end point. So delta x getting smaller and smaller, right? And as it approaches to the ending point. Okay, so we are getting here 2x plus delta x. All right. Next, let's take instantaneous rate of change of function, okay, which is going to be df. So derivative instantaneous change, and delta and the limit is average change. So df by dx is equal x squared prime, right? This is going to be 2x. Or through the limit also you can write down same thing. df by dx is the same thing as limit when dx approaches to 0 and 2x plus delta x is equal to x. So what do we have? Practically, this is the average one, average rate of change. I mean, not this one. Average rate of change. Rate of change. That is a vector. Vector quantity that is numerically equal to displacement per unit of time. And it has direction. So shortly saying it's velocity, right? Average velocity. So the average speed, and it's a speed with the direction, right? It gives us a velocity. So the average speed is in the same direction as the movement. So first, this average rate of change, it's a limit versus instantaneous rate of change, which is derivatives. And what is instantaneous speed of the point? That is the instantaneous speed characterize the movement at a certain point in time. So while average shows the average speed here and plus direction, let's say going this way, that will be our delta f by delta x, which is a limit change, and df by dx, it shows the velocity. It's instantaneous rate of change at a given time. At this time, at this time, at this time, okay? Okay, now, besides of first derivative, we can take a higher level of derivatives. Let's assume we have y is equal x to power 5. I'm taking simple things because derivative is not my primary focus. But the meaning of these higher order derivatives. So if y is equal x prime, x to power 5, then y prime is equal 5x to 4, right? Y second derivative is equal 5 times 4x cubed. Y third derivative is equal 5 times 4 times 3 x to power 4. Y to power 4, after 3 we put like that. Y to power 4 is equal 5 times 4 times 3 times 2 x, right? And y to power 5, so this function has so we will have 5 factorial, right? Because this time it's going to be derivative of x is 1. So 5 times 4 times 3 times 2 times 1, right? And derivative degree 6, it's going to be 0 because derivative of constant is 0, right? So sometimes we can get the general formula for the nth order derivative of the function. So for example, let's see, we have y is equal, let me go down here, y is equal e to power ax plus b, okay? Then y prime is going to be a e to power ax plus b, right? Because what do? You take derivative of e to power ax plus b, and that follows the derivative, the formula that e to power x is equal e to power x, right? So if you replace e to power x, it's getting same thing, e to power x. And then you get inside an ax plus b. Take derivative of ax plus b, and it's going to be equal a, right? Okay, next one. Derivative second derivative. It's going to be equal, again, e to power ax plus b. And in front, we are going to have a squared, right? Another a comes out. Y to power third degree, it's going to be e to power ax plus b, and here it's going to be a cubed, right? So from here, we can write down the general formula for derivative of nth order. So, and it's going to be derivative of nth order is going to be equal a to power n, right? Look here. degree 2, here we have 2, degree 1, we have degree 1, degree 3, we have 3. So since here I have degree n, so a to power n, e to power ax plus b. So note that the resulting formula for the nth order derivative is also valid for n when n is equal 0. Well, let's see. When n is equal 0, well, rather saying I can write down like this. Y to power 0, it's equal e to power ax plus b, and this is equal our y, right? Original, the given y originally. Okay, another example. Derive a general formula for the nth order derivative. Okay, we have y is equal 1 over ax plus b. So first derivative, y prime, it's going to be negative 1 ax plus b squared times a. How did we get this? So I am representing here ax plus b to negative 1, right? This is going to be equal negative 1 ax plus b, negative 1 minus negative 1, right? And times derivative of ax plus b. So this is equal, this negative we have, ax plus b derivative is equal a, right? And we have ax plus b to power negative 2, which is equal negative a over 1x plus b squared. Well, I wrote down this way because, so this way it's going to better see the pattern. Okay, as I go to further a higher order. All right, so let me change this color so you will see that this was drafting. Okay, next one. Second derivative. Y second, it's going to be negative 1 times negative 2 ax plus b squared, actually cubed, I'm sorry, times a squared. And then if you do third derivative, it's going to be negative 1 times negative 2 times negative 3, right? Ax plus b to power 4, a to power 3. Okay, and this way, looking at this pattern, we can say y, derivative of y to the degree n, which is nth order, right? It's going to be equal, let me write down the original problem, 1 over ax plus b to the derivative of this problem to degree n. It's equal, so I can write down everywhere I have negative 1, right? Let me put this one also negative here so you can see better the pattern. It's going to be negative 1 to power n, and n factorial, because I have n factorial. Look, I have negative 1 factorial 1, negative 1, and then times 2 of them. 3 times 3 of them, based on how many degree you have. This many multiplications of the sequence you have. Degree free, you have negative 1, 2, 3, and so on. So it's going to be n factorial and then ax plus b everywhere. And it's going to be n plus 1. Look here, 2. We have here degree 2. We have here degree 3. We have here degree 4. And we are getting n plus 1. And a multiplying by a to power n, right? So degree 1, degree 2, degree 3, and so forth. So this will be general formula for the nth order derivative of the function. Okay, and for n is equal 0, this formula will give us correct formula for the function of y, original formula of function y, right? The same way like previous. And let me do one more time. Okay, I'm going to take general formula for the nth order derivative of the function. So we have y is equal natural log 1 plus x. Okay, so we have y prime is going to be equal 1 over 1 plus x, right? Because natural derivative of logarithm x is equal 1 over x. So if it's 1 plus x, it's equal 1 over 1 plus x, and derivative of 1 plus x is going to be 1. Okay, next, second derivative is equal 1 plus x to power negative 1 prime, right? That's going to be negative 1 times 1 plus x to power negative 2, which is going to be equal negative 1. Let me put this negative here, and 1 plus x squared. Okay, third derivative is equal 1 plus x it's going to be negative 1 plus x to power negative 2 prime. It's going to be negative 2, right, times 1 plus x to power negative 3. So we are getting negative 1 times negative 2, right, 1 plus x to power 3, which means y prime, y to third order, for the third order derivative is equal negative 1 times negative 2, 1 plus x third. Next, y for the nth order, okay, derivative to the nth order of derivative, it's going to be equal, what an ugly y, is going to be equal. So let's summarize what we have. So here we have 1 is with plus, and then 1 is with minus. Second, the second order of derivative, you have 2 minuses, which is going to be plus again, right? So it's switching plus, minus, plus, minus. Therefore, what is it going to be? It's going to be how to get plus and minus, plus and minus. We're going to put negative 1 and n minus 1. So which means when n is odd, minus 1 is going to be even, right? You will get plus. And when n is even, minus 1, you are getting odd, and you will keep this negative sign. and n minus 1 factorial, because look here, factorial of 0, it's going to be 1. Here you have 1. And then factorial of 1 is 1. And here also you have 1. And then you are getting negative 2. And then you get 4. If you take the fourth order derivative will be negative 1, negative 2, negative 3. Fifth order derivative will be negative 1, negative 2, negative 3, negative 4. The bottom line is this multiplication, this factorial fall by 1 behind of nth order. So we have order 3, right? Third order 3 of derivative. Here you have 2. Then fourth order derivative you will have times negative 3 also. Fifth one, negative 1, negative 2, negative 3, negative 4. Therefore, I wrote down n minus 1 factorial, and at the bottom in denominator we have 1 plus x to power n. Okay, let's solve next one also, since I'm doing y is equal 1 over x squared minus 5x plus 6. So before I take derivative, I'm going to simplify this. And this is going to be equal, y is going to be equal 1 over x minus 2 times x minus 3, which is going to be equal 1 over x minus 3 minus 1 over x minus 2. Okay. Using formula, we got in this example, where is it? This one. Using this formula, ax plus b to power n plus 1, I can write down here. Let me copy and paste so we can see. I'll write down right here. And then I'll clean it, I'll take it away. So it's going to be equal y to power, the nth order derivative. It's going to be equal 1 over x minus 3 minus 1 over x minus 2 to the nth order of derivative, which is going to be equal, right? Let's see. It's going to be equal 1 over x minus 3 to nth order of derivative minus 1 over x minus 2 nth order of derivative. And following this rule here, this formula, we are going to get, so same way, it's going to be negative 1 to power n factorial, x minus 3 n plus 1 to power n plus 1 minus, and we are getting here negative 1 to power n factorial over x minus 2 to power n minus 1. Okay? Because what did I use here? Let me move this formula also, not formula, the general form. so you can understand what's happening here. Okay, I need to show that this is, we are not, doesn't belong to this. So look here, 1 over ax plus b to nth order derivative, and it's, I got exactly same thing, right? Look, 1 over x minus 3, and we take nth order derivative of function. Same thing here. And that's why I follow this a general form from here. Okay? This is, oops, here it's supposed to be plus, I'm sorry. Yeah? You see this, it's matching this and this, the form. Therefore, we have this general form of nth order derivative, so I just apply this nth form of derivative. Okay. Next, I have y is equal sine x, so y prime is going to be equal cosine x, which is equal sine x plus pi over 2, right? Cosine is always ahead of, sine is always ahead of cosine by pi over 2. Next, second derivative is equal negative sine x, which is going to be sine x plus 2 pi over 2, right? Why is that? Because I have here the negative, it's an odd function, sine x is equal negative sine x, and I am getting, I can make 2 pi circle, right, and half a pi, so I will get the opposite sign, right? And then y third derivative, it's going to be negative cosine x, right? Because we have negative sine x, derivative going to be negative cosine x, and this time it's going to be 3 pi and half. And y to fourth order of derivative, it's going to be sine x, which is equal sine x plus 4 pi and half. So with each differentiation, the sign argument is shifted by half a pi, and therefore we can write down y for nth order derivative is equal of x, let me write down here, of x, it's going to be sine x, taking derivative of nth order, and it's equal sine x plus pi over 2n, right? And times. Look here, indeed, we have, put n instead of 4. So we have 4, 4, 3, 3, 2, 2. And here is the general formula for this case. And if we have, if x is equal 0, then y, let me write down, nth order derivative of 0, it's going to be equal sine pi over 2n, right? And this is going to be negative 1 to power k minus 1, if n is equal to k minus 1, right? And you understand why, because we already did in previous problems, I already showed several times. And when n is equal to k, one shows even, this is going to be even case, this is going to be odd case. Okay. And a similar case is going to be with, if I take derivative of cosine, which I'm not going to do it, because since you have sine, you can do cosine. So this is how we learn to do nth degree, general form of nth degree of derivative. Now, the special interest, like I said, represent derivative of first degree. Let me write down. First degree, because this is, we call velocity, represent velocity first degree. Second degree derivative is we call acceleration. That's the very acceleration when you push on in the car, when you accelerating the car, which means if velocity is going to be distance prime, s is a distance prime, 2 is a acceleration, you take, and that is equal your velocity v. Acceleration is going to be v prime, okay, it's going to be acceleration a. And the third degree derivative, it's going to be jerking, when you jerk the car. Okay, it's a rate of change of acceleration. It's going to be a prime. It's going to be jerking. And fourth one, it's going to be Jones or snapping. Snap. When you are snapping the car, that's what it's going to be. Okay? Let's say, let me mark down as a J, and J prime, it's going to be our snapping. So these four derivatives have meaning and importance, and they are known under velocity, acceleration, jerking, and snapping. And the further orders of derivative we use as we need. Okay. Thank you for watching. I hope you liked it. It was interesting. At least I like this topic. It's interesting. And I'll see you in next video.